Again, class, good evening. Our topic for today is series parallel diode circuits. In terms of complexity, medyo mas challenging ang series parallel diode circuits. Pero I don't know, may perspective na mas, for me, no, mas ayun siya because mas dali ta assume, no? Mas dali ta maka-assume na forward bias ang isa ka kuan, no? Ang isa ka diode. Mas dali na to or I mean okay ra og i-assume na to initially again kung nga forward bias siya or ang diode, no? This I think the same gawon sa purely series diode circuits. It would be made apparent sa solution if correct ba gina atong solution or not, no? Pero yeah, I think ako maglipog ko nga ay pagka even though mas complex iyahang circuit, no, tanawon ang form sa circuit mas complex compared sa series. So may pagkasayon ang pag-analyze, no? So what am I talking about? I think that will be made that will be revealed sa mga following examples of ito. So let's say for example this one, this circuit. So this belongs under the category of series parallel because ang atong diodes we have two diodes that are parallel with each other. Okay? Dili na sila in series together. So if in any class, what would you your guesses? Again, guesses are fine initially. Lagi problema sa mag-guess. So before we proceed, the diode voltage for silicon is 0.7. And how much gani ang diode voltage for gallium arsenide? Gas? Sa nakadumdum? Ila? 0.7 ang silicon. How much for gas?
0.3.
0.3. That's for germanium, ang 0.3. Sige, if wala pa, if nakalimot mo, that's 1.2. Okay, so 1.2 volts ang forward bias voltage sa gallium arsenide na diode. Now, what does this mean? Okay, sa implication, what's the effect if we place place two different diodes parallel? Sa effect niya. What do you think? So in terms of current, I think it's no problem for us to assume in terms of current lang again, duha man kabuk ang conditions sa atong diodes from forward bias. We have the current and the voltage. In terms of current, I think dili ta masayop if mag-assume ta nga mo coincide ang direction sa atong source. So direction sa current sa diode. So if this is a 12-volt source, dito na iyahang direction sa current, I node, so mutunga na siya. One would go here, another one would go here. And mag-meet na sila aning node. Balik lang sa ground. No? So yan ang direction. So yeah, I think okay lang nga i-assume nga ang direction sa atong current sa diode is that way. Coincide sa direction sa source. But what about ang voltages? Review lang sila gamay, no? Or reminder. So, from physics, no? Maybe. Or from circuits 1. Or from high school basic circuits. let's say we have two resistors, R1 and R2, and we have a source equal to 3 volts. How much is the volt without solving? No, hindi mo solve. How much is the voltage across resistor and how much is the voltage across resistor 2? So I'd like to give an answer. Kung may answer sa chat, pwede na nyo i-type. I mean, if na may answer, pwede na nyo i-type sa chat. If di mo maka-on of microphone. 3. Okay, so thank you, Daniel. Diba? From because the two resistors are purely parallel with respect to the source, hindi na kailangan solve. 3 volts kita ang voltage pod sa R1 and R2. So although this is not a purely parallel circuit, but the two diodes are purely parallel with each other. So at least kanis lang duha, purely parallel na sila. So kung atong, I don't know, balihon ang atong kuan, i-move na to sa other side ang atong neck. Butang ta lugar dili og source. Ayan na. Whatever this would be the source, kung ang voltage sa atong diodes. But these are not ordinary circuit components. No? These are diodes. Again, ay mga some form of rules na directly ma-apply as we have observed sa mga previous examples. So in this case, so I think there's no point much of guessing na ako na lang sila iinan. What would happen, class, is the diode that has a lower forward bias voltage will be the first to turn on. So just try to think of the two diodes as bottles of different sizes. No? Kanisha is 1.2 ml, 1.2 liter na siguro. 1.2 liter, kani is 0.7 liters lang. And natay gripo dire. So i-fill up lugar sa atong gripo or sa atong water source. Kada siyang analogy kay conjugate kay siya, swak. Water na to padlong sa atong mga bottles, 1.2 liter, 0.7 liters. Which of the two bottles would be filled up, the 0.7 or the 1.2? Obviously, di ba? Si 0.7 ang mauna og fill up. So in the same manner, so water man to gripo, pero almost the same again, no? Perfect analogy, because the battery will provide current to the circuit, and current will flow, one here and another one here. The silicon diode would be the first one to turn on. No? Siya pinakauna ma-turn on or ma-forward bias, si silicon diode. Now, once mo turn on siya, because it is already turned on, it will have a voltage drop of 0.7. Okay? 0.7 yung voltage drop. Now, as we have known from parallel circuits, just like this one, no? Sa review na to nga part sa bottom, kung pila ba ang voltage sa one part sa circuit, sa parallel circuit, mo po ang voltage sa other part, no? So, in effect, 0.7 na po ang iyang voltage dili, maximum, no? Maximum na siya. So, do you think mo turn on si gallium arsenide na diode? Yes or no? Type Y daw sa chat if you agree, yes, or type N if no. Would the gallium arsenide diode turn on? Yes or no? So okay, again mag-guess, guys. No? Yes. Okay, see. Casey, nag-say nga yes, mo turn on si gallium arsenide. How about the others? Yes. Si Daniel, naingon og no. Okay. No. Ano tayo mga tulo? Mas nagana ang no, no? Why do you think not? Sige, mutan ako ni Miles. Sige daw, Miles. Anong no man? Why do you think it will not turn on?
Guess ako, sir.
Sige, okay lang. Wag problema ng guess. Isa man. Nag-guess lang kasi mong no. Sige. Okay. Sige, ang answer kita ni actually class is no, no? So, dili siya mo turn on. Why? If you compare it, no? Compare the voltage drop to the voltage that the gallium arsenide diode would require to turn on, which is 1.2 volts. So, dili siya enough. Okay? That's why the gallium arsenide diode would be forward bias. No? Dili na siya mo turn on. So, si silicon lang mo turn on. So, that would make our circuit into a purely series na circuit. No? So, nahulog noon na purely series circuit na noon siya. Just like the previous examples na to. So, yan na lang. Okay? Di man mo turn on si gallium arsenide. So, silicon diode, forward bias. Gallium arsenide, diode, reverse bias. And itong circuit is purely series. So, performing KVL, 12 minus 0.7 minus BO equal to 0. Therefore, BO is equal to 11.3 volts. So for the current across the load, given the circuit current I, series naman siya, I is equal to 11.3 divided by 4.7. 11.3 volts over 4.7 kilovolts. Yun na siya. 2.4 milliamperes. So that's the final answer. Okay. Questions, clarifications so far? Klaro na ba? Now, what if lahi nga case? Okay. What if ni gallium arsenide? What if germanium ni? No? So what germanium? We know the forward bias voltage of germanium is 0.3 volts. Yana. So the same gapon ng situation as previous. No? So current will flow initially. So both branches kang silicon ug kang germanium. But because germanium has a much lower na forward bias voltage, siya ang pinakaunang ma-turn on. So once it turns on, imong constant ang voltage here, 0.3 na siya. So if constant ang voltage, 0.3, there's no way for the silicon diode to turn on. So the same gapon nga case. Pati nga itong may tabo. If there are no more questions for this example, next one. How about this one? We have two sources. The 20 volts and the positive 20 volts and positive 4 volts. We have two diodes in parallel in a different direction. So what would happen, class, is if you remember sa itong previous na sheet work, kung yan na gani ang atong configuration, diba, what did I say? There's no way nga current will flow because only one of these two will forward bias, ang isa is reverse. So in effect, the whole circuit maapektuhan, so wala current will flow. Pero sa kanina case, bali sa duha, isa is pasaka, isa panaog. Well, I'm going to tell you right now nga isa lang ana ang ma-forward bias, no? Again, only one. But good for this circuit na even if isa lang forward bias, current will flow across the whole circuit. So if let's say for example si germanium ang forward bias, so current will flow in this direction. Yan na. So reverse bias maka si silicon. So the opposite is also true. If si germanium ang reverse bias and si silicon ang forward bias, current will flow in this direction. No? Basta kay isa lang gid ang forward bias ng isa reverse. Pero current will flow sa tanan parts ng circuit. Now, sa kaning particular case, we have two sources, the 20 volts and the 4 volts. Si 20 volts, panaog na ang iyahang direction sa current. Si 4 volts, pasaka. So in effect, magbangga silang duha. Okay? Magbangga. What will happen? So, just like to think of it like this. One would overpower the other. Okay? So kung sa actual pa ni class, well, this is not advisable, really advisable kung i-parallel sila pure. No? Really advisable if ang 20 volts is directly parallel na to sa 4 volts. May tabuan ni is i-charge ni 20 volts si 4 volts. So if purely batteries lang doon, buto na, no? So dili na siya advisable i-connect ang two sources in parallel. Purely in parallel. So okay lang yan ng mga one would overpower the other. Okay? In effect, one would be quote-unquote charging mahulog na load na ng isa. And in this case, mas dahil na to makita kung kinsa ang ma-overpower. Okay? So obviously, mas ako mag-voltage si 20, basta kung magnitude sa voltage si 20 volts, mas kamay man si 4 volts, mas overpower si 4 volts. No? Ang effect ani is ang total actual current sa circuit would flow na in this direction. Because si 20 volts man ang mas kusgan kaysa kang 4 volts. So if mo na direction sa atong current, clearly also, si silicon diode ang mga forward bias, dili si germanium. So si germanium is reverse bias na siya. So no current will flow in that direction. And again, mahulog na atong circuit will become a purely series na circuit. Purely series na siya. So if we perform KVL ta 20 minus 0.7 is the silicon minus pwede ta mo agi din para VO. Pero diretso na lang ta, no? Minus current ni resistor times 2.2, no? IR 2K minus 4 volts equal to 0. So 20 minus 0.7 minus current times resistance minus 4. The answer, Ani. Good solve for current I. How much is I? 20 minus 0.7 minus 4 divided by 2.2. 6.95 milliamperes. Okay. So much is VO. So VO is not equal to the current times the resistance of the load alone, no? Kung mag KVL ta ani nga direction from VO to ground, no? KVL ta diha. It's plus VO minus 6.95 milli times 2.2 kilo minus 4 is equal to 0. Therefore, VO is equal to 19.3. Oh, okay. So makes sense. So VO is 19.3. You could solve for VO and put in this direction. 20 minus 0.7 minus VO. So that's the final answer. Itong na-solve so far na 2 examples, in effect, na imong purely series circuit. Purely series atong circuit. Unsa ning 11.29 kc? Okay, I think so. That's the final answer, 19.3. Mabuo ko itong mga solusyon, no? Okay. Purely series naman sila. How about this one? Same naman yung sagot itong first example. Si gallium arsenide, dili na siya mo turn on. Si silicon lang. And, may na lang, ang atong source is 1 volts or 1 volt. Enough lang siya, no? Nga mo turn on si silicon 0.7 man. Samot na di mo turn on si gallium arsenide. KVL ta 1 minus 0.7 minus I times 1K equal to 0. So the answer is 0.3 milliamperes. VO is equal to 0.3 volts. Short solution. This one. Silicon. Parehas lang duha. So, parehas lang duha mo turn on. No? So, wala problema aning circuit. Assuming the current will flow downward from 16 volt. No? So, later na to i-analyze ang mga sources. So, no problem sa atong mga diodes. Both of these diodes will be forward bias. Forward bias sila. Diba? Diba, class? 16 volts and negative 4 volts. Previously, katong 20 o 4, ang current ng 20 is mo panaog, ang kang 4 is mo pasaka. Kini, ang current ni 16 is obviously mo panaog. Kang negative 4, mo panaog po ni. No? Kaya kung positive 4 ni siya, momento ang mupasaka ang current and mubangga siya sa source sa taas. So tungod kay negative ang source sa silong, Mo-coincide na siya sa current sa taas. So dili i-overpower ni 16 si negative 4. Well, in fact, tabangan ni negative 4 si 16. How do we know that to be true? Kung mag-solve the KVL equation, 16 minus 0.7 minus 0.7. Isa lang ka 0.7 ang atong consider sa parallel diodes, either the left one or the right one. No? Doesn't matter. So, isa lang. Okay. So this 0.7 is from this silicon diode. This 0.7 is from this silicon diode. 16 minus 0.7 minus 0.7 minus current ni load 4.7K plus 4. Plus 4, yeah. So, plus 4 na siya because if ato nang i-replace o symbol na to, negative part ang nakakonect sa resistor. Okay. So if mo connect diri og minus plus, notice na mo enter ta sa negative, mo gawa sa positive. That's why positive ang polarity ni 4 sa KVL equation. So 16 minus 0.7 minus 0.7 minus I times 4.7 plus 4. That's 18.6 divided by 4.7. 3.96 milliamperes. BO, the same as usual, multiply lang na, no, okay, BO is KVL, gap na lang ta sa mga direction, no? KVL tayo, sa mga direction. So BO minus 3.96 4.7 plus 4. So therefore BO is 14.6. Is equal to 16 minus 0.7 minus 0.7. Okay. Final answer. Okay, before I proceed, any questions? Ilong tayo ta. Sa tanda? Question, no? Kasi lang, ako nga po ni-upload ang atong notes karon o ang link sa video, so pwede na nyo ma-review anytime. Next example, this one. So, di naging siya series clearly. So what would happen in any class is, remember once a diode is for bias, kung pila ang voltage drop, stick na siya ng a value. Constant na. So, dire, let's say this is diode 1. Label na lang ito para libog. So, diode 1 ng diode 2. So, once diode 1 turns on, it will have a voltage drop of 0.7 relative aning terminal. So, 0.7 volts. Kana. And notice that this portion of the circuit, this one, would get its voltage from this part. Yan ang tanawon as iyang source. So do you think the 0.7 na voltage drop ni diode 1 is enough to turn on diode 2, which also requires 0.7? So I would like to guess, will diode 2 turn on or off? I-type daw sa chat kung on ba siya or off. Off. Okay, and si Rani. Rani Renzo off daw. How about the others? I think si Renzo ang nag-fly and correct answer. No? So silicon diode 2 will be off because the 0.7 na voltage drop from diode 1 will not be enough. Okay? Because napa si 470 ohm resistor or 0.47K resistor. Mukhaan pa niya siya iyang own voltage. So ang 0.7, kuhaan pa na niya. So dili enough para mo turn on si silicon diode 2. Okay lang, no? If si diode 2 is germanium, kana. If nga niyang case, both of them will turn on because 0.3 volts lang man eh. And there's enough for the 4.7K resistor. Siya ay 0.4 then. So 0.4 plus 0.3 is equal to 0.7. Pero if both of them require 0.7, and mauna og ka-turn on si diode 1, wala na enough na voltage para i-turn on si diode 2. So, in effect, it's as if this part of the circuit does not exist. Okay, wala man nag-turn on si forward bias si diode 2. So, wala ni siya nga current. Nahulog na kanina circuit is, again, a purely series na circuit sa kanina direction. So, to solve for the current I and VO1, KVL task, so 20 minus I times 1K minus 0.7 is equal to 0. Therefore, I is equal to 0.3. 20 minus 0.7, 1K, 19.3 milliamperes. 19.3 milliamperes. So VO1, this one is the voltage that is measured sa kaninga node. No? And yung ma-measure is only the voltage drop across ng silicon diode. So VO1 is equal to 0.7 volts. About si VO2, kailan ma-measure ni VO2? Is VO2 0? VO2 is this one. Measure niya ang voltage sa kaninga terminal. So no current flows across the 0.47K resistor. So mark as if wire lang na siya. So ang ma-measure ni VO2 is ang voltage sa kanang point. So the same sila ma-measure ni VO1. So VO2 is also equal to 0.7. Ayun lang siya. So far, mabuo na itong mga solution ba? And notice also nga, all of the time, assume ko nga ang mga diodes kay forward bias. Dali na ma-determine kung kinsa ang forward bias o kinsa ang reverse bias. Okay. About this one, ito na medyo challenging eh. Diba? So, kasi difference sa ni class sa katong kani. This one. The first example na ito na solve kanina. So we have silicon and gallium arsenide in parallel. This one, si silicon o gallium arsenide are also in parallel. Pero kung compare natin sa katong circuit, sa kalahian, what's the difference? Kasi yung na-observe na difference. Na yung nadungag sa circuit. Ang nadungag is the presence of these resistors. So sa kaninga branch, di na siya purely parallel sa kaninga branch, or at least ang diode sa sa branch sa taas is simply parallel circuit compared sa in relation to sa diode sa bottom ng part. So may tawa ni class, both of them will be forward biased, no? Or we could assume na both of them would be forward biased initially, no? Unlike before. So dili na mag-work sa kaninga case katong ato analogy nga gripo, no? And natay 1.2 ug 0.7 nga mga bottles because simply of the presence of these resistors. Because of the presence of these resistors, no matter pilang voltage drops ng mga diodes, 0.7 kang silicon, 1.2 kang germanium, current will flow. Current will flow here and there. So kung ato siyang i-draw, maging aning itsura sa circuit. May itsura sa circuit na to. So if nga ning itsura, actually class natin lain na efficient nga circuit tool gamiton except nodal analysis. So I hope naka-remember mo. If wala, so ako mo mag-initiate nga mag-review. No? So if nodal analysis itong gamiton, let's assign this node the name VA. So VA na siya. So using nodal, metabo is natay tulo ka branch, no? Isa kana, another one here, another one there. So ang nodal equation sa red na part is this. VA minus 10, 0.7. Ito ba? Minus o plus? Anong plus 0.7 man? Kung siyang polarity sa itong silicon. Plus minus. Asa man mo gawa sa itong current. Sulod sa negative, mo gawa sa positive. Sa source, mo gawa sa positive, sulod sa positive, mo gawa sa negative. That's why VA minus 10 plus 7 divided by 2K. 2,000 na lang. Plus VA, same gap, no? Minus 10 plus 1.2 over 2K plus VA minus source, yeah, over 2K equal to 0. So may itong nodal equation. Ang red line sa circuit is represented by this expression, so nodal equation. Ang green would be this one, and ang purple, okay, kana. So one equation na unknown. So that equation, VA is equal to problem shift solve. We could shift solve this one. 10 plus 0.7 by 2K plus VA minus 10 plus 1.2 by 2K plus VA over 2K.
Hello, good evening, everyone. I'm Stephanie Grace.
So the answer is 6.03
volts.
volts.
University, taking up business information management and currently connected at
So this is not yet the final answer,
for
no?
10
This is the
years.
answer.
And
Wala na final answer. VA is 6.03, which is also equal to VO.
Thank you.
The final answer. Wala gyapon din solution. Complex lang siya tan-awon. Pero wala na siyang answer. Kung gusto nato makuha ang current sa individual branches, okay, pwede nato ni-solve individually. No? For example, current sa silicon. Kanila nga portion, no? Wala siya. Wala siyang expression sa current. So, 6.03 minus 10 plus 0.7. Okay. Basig na icon, di ba? Basig na click. Negative siya. Ayan, sa function magnitude sa currents. So current sa silicon diode is equal to 6.03 minus 10 plus 0.7. Although negative siya, should sa current is 1.63. Sa gallium arsenide, kanilang yapon yung expression. So 6.03 minus 10 plus 1.2 1,000. .38 milliamperes.
Hindi.
So sa load, it's just VA over 2,000 or 6.03 divided by 2K. Pwede kaya po ni-add na ito ng duha, no? By virtue of KCL. So, okay lagi po dili. So 6.03 divided by 2,000. 3.01 or 3.02 milliamperes. Mga answers, voltage and current. Okay. Any questions? So far, ilang, no? I have confidence man, Diode, na if ever na mo yung mga na, when you ask ako after reviewing the video or referring to our notes. Ask them, as example. That's the what ni siya ka-case. Kasi lang, no? May lang mag-practice kita sa mga nagdidagtanaw mga diode circuits. Mag-charge ako device class, So, bitang tanang po microphone kaya para makapansakusok ng charger. Maklaro lang tingog yapon. Okay ba?
Yes, sir.
Good. Sige. So last example na to this evening is this one. Almost palagi siya sa previous, no? Same siya aning circuit. Yeah, so panggid ni nodal. We have 4 cases for this one. First case, when V1 is equal to 10 volts, and V2 is equal to 0. Second case, when V1 is equal to 5 volts, and V2 is equal to 0 gapon. Third case, when V1 is equal to 10 volts, V2 is equal to 5 volts. Last case, when V1 and V2 both 10 volts. So, ano siya itong given cases. Okay, for the first case, nodal gyapon ta, no? Let's assign this one as VA gyapon. So VA is equal to VO. Pwede lagot VO, pero VA na lang, no? So VA. So, the equation ta, isa dili nga branch, isa dito, o isa dili. Another side note, D1 and D2 are silicon. Okay. So maybe I'll just answer the siguro. The first one. Okay, para naman sa answer tanan. I mean parehas loud o process. Just answer the first one. You could practice all the others later. So yan yung sa itong nodal equation class. So VA minus V1 plus silicon man sa do, so 0.7 over 500, 0.5K man, so 500 plus same gapon VA minus V2 plus 0.7 over 500 plus VA over 9,500 equal to 0. So kani ang current na kung ato na i-solve alone, assuming na kung ato si VA, that will be the current sa red nga branch. Kani sa green nga branch. And kani sa purple na branch. Okay. The first case, V1 is 10, V2 is 0. So, sino gawas? VA minus 10 plus 0.7 over 500 plus VA minus 0. 0 man si V2. Plus 0.7 over 500. Notice ang assume ko nga si D1 o D2 kay forward bias. Dili gani tuod mo ma-make obvious na sa solution. So shift solving, kabalo mo shift solve sa inyong baon calculator. Plus si VA. How much is VA? Type daw sa chat kung kabalo mo shift solve. So one equation, one unknown na niya, si VA ra. If yun yung i-shift solve, VA is 4.19 volts. Okay. 4.19 volts. Now, may tabo ron. At ay bagong revelation. Initially, I assumed na si D1 ug D2 kay forward bias tanan. But kung atong tanawon ng answer na to sa VA is 4.19. Okay, so 4.19 na siya diha. Which is larger. Diba? So, one day ha. Ang nigawas ng answer dire, VA is 4.19 volts. Remember, V1 is 10 volts and V2 is 0 volts. So if natay voltage drop na 4.19 here, although mas dako si 10 volts kaysa ka 4.19, ang may tabo lang is i-overpower lang ni 10 volts si 4.19. That's why current will still flow in that direction. But si 4.19 is mas dako pa kang 0 volts. No, dili ma-overpower, of course, ni 0 volts si 4.19 kay 0 man siya. So current should be flowing in this direction because mas dako si 4.19 kang 0 volts. Okay? Magbutang na lang kong statement dire. Because VA is greater than V2 or 4.19 is greater than 0, of course. D2 or diode 2 is reverse biased. So ang effect day ani is na reverse bias si diode 2. So because reverse bias si diode 2, that branch does not exist. So dili na ni mag-exist na branch. And we recalculate our answer. So temporary na ng 4.19. Okay, so temporary na siyang answer. In effect, purely series circuit ang atong output, no, or outcome. Series circuit. So kung mag-KVL equation ta, so temporary ng 4.19, no, na answer, na voltage diya, di na siya absolute. Okay, mag-recalculate man ta. Kung akong assumption na forward bias si D2 is wrong man, no, because again, VA is greater than V2. So that branch does not exist. So purely series na siya nga circuit. Kanila nga circuit, wala na siya nga circuit di ang ga-exist. No? So di na siya ga-exist. So akong i-recalculate. KVL ta in color being in that direction. In that direction, we do a KVL equation. So 10 minus current times 500 minus 0.7 minus same current because series naman siya times 9,500 is equal to 0. Therefore, current is equal to 10 minus I times 500 minus 0.7 minus I times 9,500 equal to 0. Shift solve. Answer is 0.93 milliamperes. Therefore, VO is 0.93 times 9.5 is equal to 8.835 volts. Final answer. So, tsada ni siya nga example class. No? Dos tanan. So, sa initial na to, nga nodal equation, this is our general nodal equation for all kinds of cases. No? This will work for case B, case C, and case D. You could practice solving case B, C, and D later, but you'd still use this general nodal equation. And if i-plug na to mga cases, munang nakuha na akong answer 4.19, which is greater than 0, V2, turning diode to off. So purely series circuit today siya. Try to plug in 5 daw. Dire, no? So practice nyo later. Try to plug in 5 there. Or 10 here and 5 here. Same sa case C. Basta mag-gauss gani that VA is still greater than one of the sources. Meaning, ma-cut off na siya ang source. Okay. So remember my notes for this example. All right. So this is a good example to practice on. I hope try ninyo solve si B, C, ug D. I might think na i-assignment lang na sa inyo para resolve yun ninyo tuod. Okay? Pero bitaw, any questions? Was it clear?